my amazing Enlites. Welcome to the Zero to Superhero series, and you are on Enlite channel, the dedicated English medium channel for all the students who want to crack JEE, NEET, KVPY, BITSAT, CETs, boards, you name it. Welcome aboard. Hi Magita, good evening bachalo. I hope you guys are doing great, and today's session is all about electromagnetic waves. And you know what? Deliberately I am choosing all the term 2 topics of 12th standard because it will be useful for you in boards. Obviously it's going to be useful for you in JEE, NEET, KVPY. But yep, remember, this is an alternate way of preparing for boards so that you're killing 2 birds in 1 stone, isn't it? And thank you very much for joining in. And those of you who do not know me, well, my name is Shreyas and I'm the physics master teacher, and you can get to know more about me on my Instagram handle as well. And in today's lecture, we are going to start from displacement current, your Maxwell's equations, electromagnetic waves, and how do they propagate, the speeds, their intensity, pressure, and the spectrum, and also the applications of the electromagnetic waves. So that's what we are going to do in today. And first of all, before we begin the session, a big thank you to all of you to make this family big. And today, in the afternoon, we have crossed 1 lakh subscribers. That's 100K. Hello, Ankit, Azruddin. Thank you so much, Daljan. Thank you, Hannah. Hello, Anisha. And yes, Mansa, I'm just wearing my new glass for, UV protection and blue filter and all of that. So I read your comments too on the community post. Some of you have commented. Yes, Yuvashri, I read your comment too. Thank you guys so much for all the love, and it means a lot. And trust me guys, I'm not going to celebrate it too much, because if I start celebrating and if I start becoming very happy about it, then I will not work harder. I want to work even harder. Now we are not going to be happy with 1 lakh. The next target is 5 lakh. Yes, 500K. We are going to reach there soon too. And it's all because of your love, your support, and also the feedback that you give us helps us, motivates us to conduct more classes, to come here with full energy, to make sure that we dedicate all our time, energy, money, everything for you guys. So we take a lot of hard work, not just all the teachers whom you see on the front of the screen, but so many other people who make the content, who write the description box, who handle the chats. So many other people are involved who help you make that makes that experience better. So yes, it's the time for the silver play button. Yep, 1 lakh means silver play. Yes, very true. So let's begin, and I'm pretty sure we will reach there. And guys, some of you might have already, probably you might pass out by the time we reach 5 lakh. So don't leave us. Once you are an Enlite, you are always an Enlite. Once a Vedan, always a Vedan. Once a warrior, always a warrior. Remember this line, okay? So let's start, and thank you for joining in. I hope you have hit the like as well as the subscribe button. Okay, so let's start with the first concept of this chapter. This first concept is not important from the board's perspective, but from JEE and NEET perspective, it is very important. So let's look at this, and that is basically the concept of the displacement current. And this concept comes from the fact that just like an electric charge, what does an electric charge create around it? Electric charge creates electric field and electric potential around it. Everybody understands this? Yeah. Hi Steve, hi Surya. Okay, so electric charge creates electric field around it. If you bring a magnet, what does it create? Magnetic field around it. Do you remember Faraday, what he did? Faraday moved magnets inside and outside the coil, or he moved the coil around the magnet, and then he found that moving magnets or changing magnetic fields create electricity. What do moving or changing magnets create? Changing magnetic fields create? They create electricity. Electric charges, electric field. Magnets, magnetic field. Moving magnets, electric field. Hence, moving charges will create. Come on guys, now this is easy to remember. Electric charges, electric field. Magnets, magnetic field. Moving magnets, changing magnetic field, electric field. So moving charges will create, what will it create, guys? It will create magnetic field. And this is the whole idea of an electromagnetic wave. So when you take a vibrating charge, it will also create electric field, but it also creates magnetic field along with the electric field. Yes, correct, Mansa. So when you have a charge which oscillates, which vibrates, which goes back and forth, then it not only creates electric field, but also simultaneously there is a magnetic field which is created, and together the electric field variations travel with the magnetic field variations, and that makes up something called as the electromagnetic wave. You are creating a disturbance, the disturbance propagates in every direction, and that is your electromagnetic radiation. The light, the infrared, the X-rays, the gamma rays, long radio waves, microwaves, all these are electromagnetic waves. We'll talk about electromagnetic spectrum in a bit, but this is how roughly an electromagnetic wave looks like. This is just a pictorial depiction. You will not see light traveling like this. This is how the electric and magnetic fields vary. The orange one is electric field, green one is the magnetic field. This shows how the electric field changes at every point, as the rays propagate. Hello Vandana, hello Sudarshan Reddy. I hope this is clear. Now, this whole concept of, yes, we are going to see this whole concept of, displacement current. So if you have a battery and let's say, for example, there is current passing through it. If there is current passing through it, then you will notice that, there will be charges which will be built up if you place a capacitor on its way. So battery, current flows, capacitor, the capacitor gets charged. Let's say you change the voltage. Okay, let's draw this. Yeah, let's say the voltage is varied. If you change the voltage, what will happen? The current will change. If the current changes, what will happen? The charge will change. If the charge changes, the charge creates, what does charge create? It creates electric field. So the electric field will change. If the electric field changes, what will it generate? It will create magnetic field. So the whole process has been explained in this logical flow. Moment you change voltage, current changes, charge on the capacitor changes, charge changes. You will see electric field changes, You will notice that there is an induced or generated magnetic field because of that. All right, I hope this makes sense. Now, okay, let me just get my pen back. So this electric field in this region, okay, if it changes, if E is not constant, then B is induced. And we define a new quantity. Yes, we define a new quantity which is called as the displacement current. Okay, and I'll just tell you that formula and I'll also explain what is the meaning of it. Now, this normal current creates a magnetic field around it. There is magnetic field which has been induced in this case. So there will be magnetic field which will be created because of this electric field. Now, that current which is there here, actually there is no current, there is only changing field. That current which produces the same magnetic field, as that of the changing electric field is called as your displacement current. It's not your actual current. There is no actual charges which are going from here to here. Do you agree with that? Because there is a gap here. So there are no actual charges flowing from one point to the other. Everybody agrees with this? Hi Subiksha, hi AB. So that current which produces the same field as that of the actual current, or the that current which produces the same magnetic field as that of the changing electric field is called as the displacement current. So displacement current is basically the equivalent current, that produces same magnetic field same magnetic field as that of changing electric field. And the value of this displacement current, how many of you remember this? Hi Dhaljan, yes, what's the magnitude of the displacement current? It is nothing but epsilon naught into d by dt of the electric flux. This is your electric flux. This is the formula which you should know. The displacement current is the permittivity of vacuum into d phi by dt. That's the rate of change of flux through this section. So you can see field lines are cutting through. So how quickly the flux changes, that's the d phi by dt. It's not rate of change of magnetic field, it's the rate of change of electric field. That's something which you should keep in mind. Everybody with me? Cool? Yes? Alrighty? Okay, perfect. Now what happens is, okay, so I have just put up the definition also here. Now what happens is, because of this displacement current, you will notice that your Ampere's law gets modified. Your Ampere's law gets modified. So what was your Ampere's law? Ampere's law was nothing but cyclic integral B dot dl or ds, whatever you want to write, is equal to mu naught into the current. This current happens to be the actual current which flows in the circuit. That actual current is often called as the conduction current. What is it called? It is called as the conduction current. The meaning of this conduction current is basically the rate of flow of charges. The actual current which flows. The actual current, actual flow of the charges. Now this law gets modified. The current should include both the currents, because when you usually apply Ampere's law, you never bothered about changing fields. So when there is electric field also along with the actual current, maybe there is a wire which is carrying current and maybe somebody is also giving electric field, and that electric field is also changing. Then the law gets modified. You need to add one extra term over here. So what will be that extra term, my warriors? That extra term is your displacement current. That extra term is your same displacement current from before. Everybody got this? So the Ampere's loop law remains the same, just that the current should include both the currents, conduction current as well as the displacement current. So some books will also write the same equation in a slightly different way, maybe something like this: cyclic integral B vector dot dl is equal to mu naught into IC plus, what is the value of the displacement current? I just gave it to you. It's epsilon naught d phi by dt. So substituting that and multiplying it by mu naught, you will get mu naught E naught into d phi by dt of the electric field. So this becomes your formula, the modified Ampere's law. Is that fine, guys? Everybody with me? Give me a thumbs up, give me a heart. Yep. Let me know in the chat box that you guys have understood these formulas. We'll solve some questions. That's when it will enter your head. Perfect. Hi Rohit, welcome. Good evening bacha log. Okay. So now I think I just gave it to you over here, the Maxwell's modified law. So I had to put that in this slide, but it's okay. I hope you guys understood that. All right, so let's start with some questions coming up on your screen. All right, thank you Naz Mansa. All right, let's start with some questions. See, in this question, what is happening is there is a capacitor. It is charged, and due to some source, the plate loses the charge at some rate. So what is the displacement current? Let's try to visualize, and then formula wise it is very simple only. So there is a capacitor, it is charged, and due to some decay there is some loss of charge. So loss of charge, and the loss of charge is at the rate of 1.8 into 10 to the power minus 8 coulombs per second. Fair enough. So because of that, what will happen, my warriors? There will be obviously electric field between them, and this E will obviously not be a constant. The electric field will keep changing. Make sense? And what is the value of the electric field? What is the value of the electric field between the plates of a capacitor? I hope you remember that formula. The electric field is given by QA by epsilon naught. This is the formula, sorry, Q by A, sorry, this was supposed to be Q by A, and here you have epsilon naught, sigma by epsilon naught, basically the charge on the capacitor upon the area of the plates divided by epsilon naught. Everybody remembers this? Okay, why do we need this? Now I'll tell you why. Displacement current is asked. So what is the value of the displacement current? Displacement current is nothing but epsilon naught rate of change of electric flux. Electric flux. Now I don't know electric flux, but I think I can calculate it. How? Through this section, how much flux flows? Think about it. Through this section, how much electric flux pierces through it? That will be nothing but the electric field into the area. Correct? Now, out of these two terms, which one is changing? Is the area changing or is the field changing? Obviously, the field is changing. So, the constant should come outside the derivative. So, bring that A outside. So, I'm just going to shift that A outside. So, it will be epsilon naught A into dE by dt. But wait a minute, I know the value of E. E is Q by A epsilon naught. So, instead of writing this E, what I will do is I will write this down as Q by A epsilon naught. Now the next thing comes, A is a constant, epsilon naught is a constant. So shift these two outside. So what will I get? Observe, epsilon naught A by A epsilon naught into dQ by dt. The best part is epsilon, A gets cancelled. I am just left with dQ by dt. What is dQ by dt? The rate of loss of charge or the rate of change of charge. Hence, what is this value of dQ by dt? It's basically this one, isn't it? The rate at which charge is lost, coulombs per second. Hence, this answer should be 1.8 into 10 to the power minus 8. Hence, the displacement current value is 1.8 into 10 to the power minus 8, which is option A. Yes, correcto. You guys are absolutely bang on. Very good. Hannah, Pranav, white level. My point over here is, you will always see this. You will always see this. What? The displacement current. The displacement current between the plates of a capacitor will always be equal to the conduction current. Always. So, you don't even have to do all these steps in the exam. The trick that you guys will use in the exam, will be, look at this and see that the charge is changing. If the charge is changing, that means if this is the rate, this itself should be equal to the conduction current, rate of flow of charge, coulombs per second. I hope this is clear. Yeah. Hence, that's the reason why you should not even bother solving this question so much. Just mark the same thing over here. What is the reason of 60 microcoulomb? No use. It was just there to confuse you, Mansa. Bobby, I will reply, bacha. I'm so sorry, I forgot, but I'll reply. Okay, happens. Sometimes I miss. There are so many other comments also. I keep on replying, and sometimes it just slips. Okay. Alrighty. Yes, Mangalam, we are, and thanks to you, bacha log. Okay. So I hope this much point is clear. Can we move ahead? Okay. Next question coming up. The conduction current is the same as the displacement current when the source is. Come on, this one is easy. The conduction current is the same as the displacement current when the source is AC, DC, both, none. Come on, this one is easy. You should be able to answer this within 20-30 seconds, not more than that. Waiting for your replies, come on. So Bobby, just put up which branch you are looking for, and are you looking for home state or are you looking for, something else? Just let me know. I'll definitely help you out with that. Okay, so Sonalika, these are not powered glasses. These are normal glasses. I can see even without these. These are just, with the Blu-ray filter, and it has UV protection and all those things, so that, all the studio lights which are there, and I'm continuously seeing the screen. So it will just, keep my eyes a little bit safe. That's why. Okay, in fact, you guys too should use it in case you are in front of the PC or in front of too many lights for a long time. Yeah, so cool. Okay, a lot of you are saying only A or B or maybe C. AC, yes, it is AC and DC both. Yep, guys. So I'm not sure, Deep Deva, where are you referring about electrostatics? I'm not sure which session you're talking about. Yep, so guys, understand, when I wrote conduction current is equal to the displacement current, this is true even for DC. Okay, because it really doesn't matter whether it is DC or AC. This has to be true for each and every situation. In fact, you will notice that all the kinds of currents will produce magnetic field if there is no change in the magnetic, if there is AC current or whether there is DC current, they will be equivalent. You cannot separate them out. So the answer is for both. Please keep this in mind. Okay, next question I have in front of you, and here it is: which of the following equations is wrong? E dot area is equal to Q by epsilon naught, B dot area is 0, E dot ds is minus d phi by dt of magnetic flux, B dot ds is equal to mu naught I plus epsilon naught mu naught d phi by dt. Okay, come on, let's see how many of you can get this. Deepdeva, tomorrow I will be teaching if I'm not wrong, semiconductors. Okay, it's not electrostatics because semiconductors is a term 2 topic. But if you want electrostatics, please watch my Pathfinder. I have conducted some 7 or 8 classes on just electrostatics, Gauss law. Watch those lectures in detail. All the concepts have been covered. Also, you will see one shot of zero to hero electrostatics. So by the time I come to zero to superhero electrostatics, it will take some time. Okay, come on guys. Let's see how many of you can solve this. Which of the following equations is wrong? The correct answer is yes, it is none. The answer is none because all these equations are correct. In fact, if you notice, it's in disguised form. The first one is actually your Gauss law of electrostatics. If you have some charges which are there, and if you draw a Gaussian surface, then whatever charges are inside, only they are responsible. The charges inside are responsible for the electric flux. This one is basically telling you magnetic flux is always 0. This is also true because you will notice for this particular equation, this represents your magnetic flux. Magnetic flux for closed surface is always 0, and the reason for that is because magnetic field lines are always in loops. So you always find loops of magnetic field. So because of that, there is no termination or origination of the magnetic field lines. So whatever field lines enter in, they will exit out when you talk about magnetic field. Hence, no net flux can be ever created for a closed surface for magnetism. That's your Gauss's equivalent law for magnetism. If you notice this equation, this is actually speaking Faraday's law. Okay, this E dot ds is actually dV, the potential difference. E dot ds is actually speaking its potential difference in a loop, across a loop, which then happens to be your induced EMF. Voltage by distance gives you field into distance gives you voltage difference. So the voltage difference across a closed loop, which is also called as the induced EMF, is your rate of change of magnetic flux. This is nothing but your Faraday's law. That's it. This minus sign has come because of Lenz's law. So this minus sign is because of your Lenz's law, which says that the induced electricity is always opposite to the changing magnetic field. That's all. How many of you remember this? And this one, this is your modified Ampere's law. I just told you about it just some time back. This is nothing but your Ampere's law. If you notice, this one is your conduction current and this one over here is your displacement current. That's all. Do you see that? Yes. So all the equations are correct. These are the simple representations of Maxwell's equation. Together they are called as Maxwell's equation, but you will also see Maxwell in a very different form when you go to higher grades, especially when you talk in terms of divergence and all, curls and all of that. So don't worry about that. But right now, all these things, for your current knowledge of mathematics, they are correct. Okay, moving on to the next part. Hi Sarag. Yes, Ankit, it was Ampere's loop law. Now, the next point over here is how do electromagnetic waves propagate? What are their equations? What is the speed? And all of that. Okay. Now, the point over here, which I made just some time back, was that whenever field changes, either electric or magnetic field, it creates the other field. Electric field creates magnetic, magnetic creates electric. Like you can move a charge and create electromagnetic wave, you can even move a magnet and create electromagnetic wave. Now, if you notice how the electromagnetic field moves in your 3D space, it's something like this. Forget the blue line for now. Just concentrate on the red arrow mark or the green arrow mark. The red or the green. If you take the red as the electric field, the green is your magnetic field. So you will notice that there is an electric field wave, the red one, and a magnetic field wave, the green one. Both are perpendicular, both move together, both depend on each other, and they both travel at the speed of light. Yeah, it's like a sine wave. Okay, forget the blue one. The blue one is just for visualization. If you look at it from this side or from this side, like the front view, you will see that the electric field keeps on oscillating back and forth, up and down. Electric field goes up, then it points down, then again it goes up and comes down. Magnetic field goes like that and like this. This is how it is. Is that clear? Now, one important thing that I want you to really understand is that the electric field, okay, I'll just use the same color so that there is no confusion. So the electric field, which is, let's say I'm using red color. So electric field cross, electric field vector cross the magnetic field, which is green in color, is always going to be parallel, to the speed of light. Very important. If electric field is up, magnetic field is here. Electric field is up, magnetic field is here. Electric field cross magnetic field gives me the direction of the light or the ray, or how they are propagating. Very, very important. Yes. So keep this formula in mind. Electric field cross magnetic field gives you the direction of the light or the wave. Now, like you have seen the wave equation back in your 11th standard, the sound wave equation or the transverse wave on a string equation, same way you can write the equations for an electromagnetic wave. Simple it is. It's not very difficult, guys. See, if you are talking about your electric field, instead of A sine kx plus minus omega t, instead of A, which is the amplitude, here you will have the electric field amplitude, which I will, let's say, call it as E naught. So it will be nothing but E naught sine kx plus minus omega t. Plus minus decides the direction like this. If it is plus, then where is it moving? If it is plus, then it is moving along the negative direction. If this is x, it is moving along negative x. If it is minus, then it is moving along the positive direction. So it gives you the direction of the speed of the wave. Is that clear, my warriors? Okay. Similarly, if you talk about the magnetic field's amplitude, which is B naught, that B at any instant will be given by B naught into sine cos whatever you want to use, kx plus or minus omega t. That's your magnetic field equation. Everybody with me? Everybody with me on this? Cool? Alright. Some more equations that I can give you is, if this is the length of one electromagnetic wave, that will be obviously your wavelength. That's your wavelength. and the speed of light is the frequency into wavelength. That's standard, where c happens to be 3 into 10 to the power 8 meters per second, which is very fast. More frequency, less wavelength. All right, keep that in mind. Now also remember, c depends on the medium, frequency depends on the source. This is a common mistake which many people make. So I want to make this absolutely clear. C only and only depends on the medium. Do not ever say, sir, I doubled the frequency, so speed of light should double. That will be absolute stupidity. How can doubling frequency change the speed of light? If you double the frequency, speed doesn't change, wavelength will change. Keep this in mind. The frequency is decided only by the source. And lambda, bechara, papa lambda. What is papa lambda based on? Papa lambda is based on source and the medium together. Together they will decide. That is decided in the last. Once you fix the source, fix the medium, last you should decide wavelength. Yep. I hope this is understood and this is clear. Okay, all these notes, my handwritten format will be available to you in the PDF like you have been seeing every day on Telegram. I put it up. Yep. So, next thing, let's talk about the speed. Okay. Yes. I said for NIT Surathkal only Bindu when I replied. Yes, I did. Okay. Speed, the speed of the wave or the speed of basically the light. Speed of light. Okay. In general, C is given by E naught by B naught, which is also the instantaneous value of electric field by instantaneous value of magnetic field. Also, you can write this as omega by K, which is the same thing. Omega is your angular frequency, K is your wavelength. Remember, omega was 2 pi f, K is your 2 pi by lambda. This is angular wave number. Do you remember from 11th standard? And this was angular frequency. This is what it is. Okay, these are all the same formulas. There is also another way of writing the speed of light. Let me show that to you as well. And that is basically 1 by root of mu naught epsilon naught. This also gives you the speed of light. So this is the permittivity and permeability of the medium. But if you are in a different medium, then you should not use the naught notation. Keep this in mind, because permeability and permittivity depends from medium to medium. So strictly speaking, I'll just leave it over here. Mu is going to be mu naught into relative permeability, and epsilon, which is the permittivity of the medium, will be permittivity of vacuum into relative permittivity. So all those things will change from medium to medium. So I hope this is also very clear. Okay, I hope this is clear. Understood, my warriors? Understood? Clearo? Alrighty. Hello Falcon, hello Kriti. Welcome my warriors. And guys, if you have missed the starting part, make sure you start watching it from the beginning, because I have covered all the important things, concepts, diagrams, all the important formulas, how to apply them, including problems, right from the beginning. So make sure you watch it. And if you find that something went really fast, watch the replay, or my detailed classes of all the 12th standard are there in the playlist on this channel, that too in English medium. Okay, so make sure you watch that. All right, now let's talk about intensity and all of that. Glad, yes, very good Sonalika. All right, Hari Krishna, very good Mansa. Hi Aris. Okay, now let's talk about average energy density. See, electric field carries electrical energy. Magnetic field carries magnetic energy. Electromagnetic waves have electric field also, magnetic field also. So, an electromagnetic wave has electromagnetic energy. Understood? Electric field, electric energy. Magnetic field, magnetic energy. Electromagnetic wave has both electric and magnetic field. So, it will have electromagnetic energy. We all know that the formula for electrical energy density, when I say electrical energy density, it means how many joules is there per meter cube. That's the meaning of energy per unit volume. Okay, energy density. Okay, so what is the electrical energy density formula? It is half epsilon naught E square, but this is not any ordinary electric field. It is the RMS field. Why you should use RMS? Why not the maximum or some random electric field? If you have studied AC circuits, have you studied AC circuits last term 1? AC circuits, you had RMS current. What is RMS current? RMS current is that constant DC current which is the equivalent of a sinusoidal or some varying AC current. So same way, in an electromagnetic wave, field is continuously changing. So which field value will you take? You will choose one equivalent constant field which is the equivalent of that varying field. That constant field is the RMS field. Is that making sense? Is that making sense? Aries, I just did nucleus yesterday, bacha. Please watch the replay. Okay, yesterday 7 o'clock. It's there on the channel. So that's why this is RMS, and this will then be half epsilon naught. Instead of RMS, you can put maximum value square by 2, because remember RMS is nothing but, okay, if you don't remember, RMS is max by root 2. So square it. So you are just going to get this as 1 by 2 into 2 is 4 epsilon naught E naught square. That's it. This is the electrical energy density. Now this electrical energy density also happens to be the magnetic energy density, because both are present in equal amounts. Keep this in mind. They are equal in amount. So when you add them up, the total energy density, which is nothing but the electrical energy density plus the magnetic energy density, comes out to be this plus this 2 times. So basically 1 by 4 epsilon naught E square, okay, 2 times. So this will become 1 by 4 epsilon naught E naught whole square. Okay, so this is the total energy density. Is that clear, my bacha log? Oh, no problem, Aries, happens. Venkatesh, you guys really want, because I had asked it on the polls, but not many people said ki you guys are preparing for SRM. So I was under the impression that most of you are preparing right now for boards or KVPY and JEE and NEET and all of that. So if you guys want me to, I want your spam on the community post that, sir, we want SRM JEE. Yes, if I get some 10, 15, 20 messages, then I will start doing the SRM as well. Okay, intensity. What is the meaning of intensity? Intensity is how much energy falls per unit time per unit area. So it is watts per meter square. Keep this in mind. How much energy falls in 1 second in 1 unit area. That's the intensity. Yep. So that formula is very much similar to this one. I'll tell you, very easy to remember. Intensity formula is half epsilon naught E naught square into C. That's all. Just multiply it by C. That's it. That's your intensity. Okay. So just multiply it by the speed of light. Is that clear, my warriors? Cool. Interesting, right? Okay. So how much energy falls per unit time per unit area? So if light rays are falling, okay, like this. So in 1 unit area, how much energy falls? That's your intensity of light. Perfecto. Last thing is the radiation pressure formula. Yes, last thing is the radiation pressure formula. Meaning, see, electromagnetic waves, right? They carry momentum. Light has momentum. Don't think, sir, light is massless. It does not have momentum because it, I don't think that light has mass. No, light has momentum, although it does not have mass. And because it has momentum, just like when something falls on you, imagine a pandu, okay? He is standing in front of some breeze right over here. Okay, this pandu is standing in front of the breeze. Just because you cannot see air does not mean air does not have momentum. Air has momentum, and when the air falls on pandu's face, pandu will feel that force. Pandu will feel that force. Correct, guys? So just like that, even light has momentum, and because of that you will experience force. So pandu will experience force. Now pandu also has some area, right? there will be some area of Pandu. So that force per area will give you the pressure on him. Will give you the pressure on him. Same way, if light falls on an area, the intensity of light is I. So the pressure of light on that area will be I by C, intensity by C, just I by C. If it is a absorbing surface, and if it is reflecting surface, then it will be I by C into 2 times. So if it is a reflecting surface, that's all you need to remember. I by C and 2I by C, that's all. Is that clear, guys? As simple as that. Okay, so I by C or 2I by C. Why 2I by C? Because when it is a reflector, the momentum change will be double. You would have done this kind of questions in 11th grade. A mass comes and stops, change in momentum is mv. If a mass comes, stops and goes back, the change in momentum is 2 mv. Yep, that's all. Okay, very good, Kriti. Perfecto, Magita. All right, Hannah. Hi, Shreyas. Maybe if you are regular, maybe I'll remember it. Maybe you can give some some incident, then I might remember. Hi. Okay, so what we have here, the electric and the magnetic field of an electromagnetic wave are in phase and perpendicular, in phase and parallel, opposite in phase and perpendicular, in opposite phase and parallel. Okay, let's see. Gauri Shankar, come on, bacha log, start answering this. The 2021 batch, yes, now I do, yes. All right, so, okay, Mansa saying option C. Come on, my warriors, you should be able to do this. Easy peasy, lemon squeezy question, not more than 20 or 30 seconds. C, are you sure? White devil, is it really? Guys, why do I get conflicting requests? You guys ask me for something, but you attend something else. You put something else. So guys, be true to yourself. When I asked you guys in the poll, do you want board series? Almost 70%, 80% said like no, sir. Okay, the correct answer is actually A. Oops. Who was the first person to say A? Yep, I think it was White Devil, and then Sharmaji, Gamer, and then Dalian, and then Magita too. Yes, Susil and Hannah also joining in. Guys, come on. The electric field, if it varies like this, then the magnetic field also varies with it, like that. Don't you see that they are in phase? Crest, trough, crest, trough. Obviously they are in phase, and obviously they are perpendicular to each other. Hence option A. Come on. How can they be opposite in phase? Opposite means when there is a crest, this is giving a trough. No. If this is increasing, this is also increasing. They are always in sync. Okay, keep this in mind. All right, moving on to the next question on your screen. These are series of related questions. If you get this, you'll get the next, and so on and so forth. So building up the level slowly, a light wave is traveling along the y direction. Corresponding electric field at some instant is along the x-axis. What is the direction of the magnetic field vector? I just gave you some concept some time back. Just some time back I gave you a concept. In case you have forgotten, I'll go back to that screen. Just over here maybe. Yes, on the screen the hint is there. And if you have taken the hint, you will get the answer. Come on. Electric field cross magnetic field is parallel to the speed of light. So let's move and see what should be the answer. Come on. The speed of light is along this direction. So C vector is here. The electric field is along the x-axis. This is where the electric field is. So if electric field is along the x-axis, that means I cap cross B, which is, I don't know what it is going to be parallel to J cap. I cross what will give you J cap? Think about it. I cross K, it will give you minus J. So remember, I cross K will be giving you minus J, but I cross minus K will give you plus J. right? Everybody knows this. So hence the answer is D, it is not C. I know many people end up answering C because you make a mistake. If you guys are prone to making mistakes, remember this cycle which I am giving you, it's a trick. Remember I, J, K. If you go clockwise, just like the clock goes positive. If you go opposite, then negative. So I cross K minus J. So I cross minus K, so obviously minus of that, so plus J. I cross J, K. J cross K, I cross K minus J. K cross J minus I. J cross I minus K. So clock is positive, anti-clock is negative. Okay, I hope this is clear. Madhusudan asking, why am I wearing glasses? Okay, somebody please reply on my behalf. Okay, I think I should, there is some text scrolling at the bottom, so I think I should also put up that text, okay, why am I wearing glasses? I will, maybe next lecture. Okay, coming up to the next question. So Madhusudan, basically, thank you very much for your concern, bacha. Actually, the lights are troubling me a lot from long time. I have been in front of these lights, so it started to affect my eyes too. So constantly looking at, this is also a screen, there is a light here, there, here, so many lights are there. So I need to protect my eyes, or else if I don't see, how can I teach? Okay. So during the propagation of electromagnetic waves in a medium, what do you think? Both electric and magnetic energy densities are 0, or it's half, or it's 1/4, or equal? Come on. This is simple. Jyotsna, can you see bacha upcoming sessions on the same channel? Have you subscribed, Jyotsna, to the channel? If you have subscribed, can you see the upcoming sessions, and then only you will come back to me and say, sir, I understood what you are saying. Okay. So is it D? Yes, it is D. In fact, I just told you sometime back right over here that the magnetical energy density and electrical energy densities are equal. They are in equal proportions. There is no partiality. There is no bias. Both have equal energy. In fact, that's why I added them to get the total energy and just multiplied the electrical energy by 2. So yes, it is equal. Option D. Perfecto. Let's see whether you can get the next question right. Come on, my warriors. A plane electromagnetic wave of certain frequency travels in free space along the positive direction of x. At some point, the electric field is this much. What's the magnetic field vector at that instant, at that point? Let's see how many of you can get this. So I feel multiple concepts are involved. Just go back to the slides. If you have written down the notes or made some notes, or you have the formulas, that will help you. But I would prefer you guys not looking at the formula, because then that will test your true skills. So come on, let's see if you can answer this. Electric field is given, so magnetic field can be found using a simple formula, which is electric field at any instant by magnetic field is C. So therefore B is equal to E by C. So E value, I think I know it. It is 6.3. Of course, divided by C is 3 into 10 to the power 8. So this will be nothing but, obviously I think I'll get 2.1. So 2.1 into 10 to the power minus 8. Now the thing is, this will be in Tesla. If you look at the options, this is wrong, this is wrong, this is wrong, this is correct. But luckily for us, there were no two options with different directions. Hence, I can safely assume that this is correct. But I have not even cross-checked whether K cap is correct. In the exam, will you cross-check whether this K cap direction is correct, or will you just go ahead? Let me know. Will you cross-check, guys, will the direction is correct, or will you just assume that, okay, whatever the examiner has made, it will be correct only, why check, we'll move ahead. What will you guys do? What will you guys do? Let me know. We all know that electric field cross magnetic field is parallel to speed of light. No, Hannah, you should not cross-check. Never, never. Very good, Digant Vijayan. Don't cross-check. You should not do that. That's what toppers do. They don't cross-check. In fact, if you have attended my previous classes also, I have told you, never cross-check when a part of the answer has been, proven to be correct, and you see that there was only one option like that. Don't waste your time. Okay? The only reason why you feel like cross-checking is because You are tensed, you are nervous, you feel that okay, something might be wrong, hence you end up cross-checking. So don't do that. So in fact here electric field is in J cap, magnetic field I don't know, parallel to C vector is I cap. So J cross what will give you I? Remember that cycle I gave you? J cross K will give you I. That's it. So it should be K cap. That's all. So this question mark has to be K cap. Everybody got it? Yes. Okay. There we go. That's the answer. Alrighty. Moving on to the next question. So you should know this formula. And here comes the next question. Looks scary, but it is not. The electric field of a wave is which is moving in x direction is given by E naught J cos omega t minus kx. The magnetic field at the moment t is equal to 0 is how much? Okay, let's try and do this question. First of all, if you use this and put time is 0, because at the moment time is 0 has been asked, I will get that the electric field vector is E naught and this is cos 0 minus kx and this is j cap. So electric field will become E naught. Cos of minus theta is cos theta. So sine of minus theta is minus sine theta. So this minus will not have any effect. So I can just write it as cos of kx and the j cap comes over here. Simple? Okay. Now we need to figure out what is the magnetic field at that moment. We all know electric field by magnetic field will be C. Therefore, B naught will be E naught by C. Now if you notice all the options, it has epsilon naught and mu naught. So I think we need to write C in the terms of E naught and epsilon naught and mu naught. What's the formula? Formula for C is 1 by root of epsilon naught mu naught. I just gave you this formula, right? Sometime back, if you notice, it was there right over here. Where is it? Yes, there you go. C is 1 by root permeability and permittivity is root. Yeah, it's all there. So same formulas I'm using. So let's move ahead and see what do we get now. Okay, so this will come on the top. So it will become E naught and root of epsilon naught and mu naught. Perfect. Okay, cool. Now B naught is done. I think the only thing left is the direction. So think about it. If electric field is along J cap, okay, let's make use of this fact. Electric field cross magnetic field should be parallel to speed of light. Electric field is along J cap direction. You can see that. Magnetic field, I don't know. Speed of light is I cap. J cross what will give you I? I, J, K. J cross K will give you I. So obviously this question mark should be K cap. Everybody got this? Okay. So now you have your answer. So your magnetic field will be B naught cos kx, but instead of j cap you will have k hat. So do I have such an option? I think so. Option C is correct. So just take the B naught value from here and substitute it. K hat I got it from here. Simple. Got it? So now have you gained some confidence in solving electromagnetic waves question? Shall we move ahead to the last part? Okay, I think we have one more question and then we'll go to the last part and some more questions, guys. Here comes the next question. A plane wave of some intensity strikes a mirror of some area held perpendicular to the wave. The momentum which is transferred to the mirror each second will be, okay, is, sir, how C is I direction? Oh, look over here. It's traveling along the x direction in vacuum. It's mentioned, bacha. In fact, even if you look at the wave equation, it has x term and this is minus. If it is minus, it is moving in plus x axis, which is I cap. Hence, I got C's direction as I cap. Is that making sense? Okay, cool. Let's move on. I hope, Mansa, this is clear. Okay, Mansa, is that clear, bacha? Can we move ahead? Come on, let's try and solve this question. So, the question is basically on radiation pressure, if you have realized. No, electric field is not. Electric field is not. Just check this. Wave propagating along the x direction. The electric field is this of a wave propagating in the x direction. Wave is propagating. Okay? Alright. Cool. Thank you so much, Gogster. Thank you so much. It means a lot. So when you have such a question, momentum transferred per unit time, del P by del T means the force. And force is pressure multiplied by area. The second thing that you need to notice is that there is a mirror, hence it is a reflector. Hence the pressure will be 2I by C and area will come as it is. Now just substitute the values, you shall get the answer. 2 times intensity of the light is 6. Area is a 40 centimeter square. So 10 to the power minus 4. Speed of light is 3 into 10 to the power 8. So 3 goes with 6 2 times. 2 2s are 4, 4 4s are 16. So 16 into we have 110 power, 110 to the power minus 4 power. This goes on the top, 10 to the power minus 8. So this will become 10 to the power minus 12 and this will become 16 into 10 to the power minus 11. So do I have such an answer? I think this one will be fine because if you shift that decimal inside, it will be 1.6 into 10 to the power minus 10. Yeah, it makes sense, right? This is also 1.6 into 10 to the power minus 10. Hence option D is correct. So you just have to use, your logic, 11th standard, rate of change of momentum force. Force is pressure into area. Pressure, radiation pressure. Last thing, mirror. Many people will miss the 2 and they will get exactly half the answer. But I don't think half the answer is there. But anyways, you may end up with half the answer if you do not multiply by the 2. Okay. Now let's go to the most interesting part because a lot of people like this. Yeah, is there a formula when the waves are projected at an angle theta or is it some chapter? Oh, Pramath, that is there in the photons chapter, photoelectric chapter. So light is there falling at some angle and then the force is asked, then you take the component of it. That's there in H.C. Verma also in that photoelectric chapter, not here. Okay, it is the same thing. I mean, it's there in both the chapters slightly, but more of this is there in photoelectric effect. Okay, so we are talking about electromagnetic waves, but what kind of waves are there? What are the different uses and do we classify these waves based on their characteristics? So yes, do you need to buy out the spectrum? Yes, you do. You have to. You need to know it. Now, very easy way. Remember, see radio waves. Radio waves. Radio waves are basically, very long wavelength waves because radio waves, if you want to talk to someone or there is a station that you are listening to or there is a satellite that you are communicating, generally their range should be large. So they have a very long wavelength. So that's why you have long radio waves first with lot of wavelength, usually in meters or even in kilometers. In kilometers. No, Anuttama, you don't. Okay. Now, the next thing that you need to understand, we get micro. Micro is, smaller. So you get microwaves which you use it in microwave oven. You can also remember this picture if you want. A radio is there beside a microwave oven. A microwave oven is there beside a mobile remote. Mobile remote is there beside a bulb, and beside a bulb there is a sun, and sun has, beside that you have some X-ray machine, and beside that X-ray machine you have that symbol which is nuclear reactor. So if you can remember these appliances in order also, that will be fine. You can make up your own story, you can make your own mnemonics, you can cook up something to remember it either symbolically or by the first alphabet. Is that making sense? Yep. Naga, if you want me to, I will do that, bacha. Can we just complete ray optics first? Because ray optics is also there for term 2. So by this Saturday or Monday, I think I'll be done with ray optics and then we'll do the board's preparation. Fair enough? Okay. Now we will see all these rays in detail. So basically infrared is there in your TV remote or even this remote. Okay, even this remote. This is my AC remote, by the way. I don't know whether you can see this. Okay. Yeah. So can you see any light coming out of it? Okay. And you can? No. I'm not sure. I need to check it on my screen. Can you see any light? No, right? Okay. Sometimes it shows if the camera is capable of detecting, infrared waves. Okay, light bulb obviously visible. UV rays come from your sun as well. X-rays and then gamma rays. Let's talk about each one of them. So like I said, radio waves, usually the wavelength is very large, used for communicating for FM, AM, long distance communication, all of that. The frequency is very low, wavelength is very large. You can see the frequency is in few hertz, kilohertz to some megahertz. No problem, white devil. All right, next. Okay, next. Okay, I'm not sure what you guys were saying no for. If you can, somebody can tell me what you guys were saying no for, that will be clear in my head. All right, so microwaves. Microwaves are basically used in microwave ovens because there is a big paragraph in your NCERT. Please read that. That can come as a direct application or theory point, or even in JEE and NEET as a direct theory conceptual question. What is the use of microwaves and how does microwave oven work? You should read that. So basically what happens, whenever the frequency of a wave matches the natural frequency, it resonates. You all know that. You all know that. So let's say there is some spring mass or some pendulum which oscillates. If you push and pull it at the same rate, it will oscillate with a very large amplitude. Correct? Now, even the water molecules in the food, be it rice, chapati, whatever, biryani, so they also have a frequency, natural frequency with which they vibrate. Now, it so happens that the frequency, natural frequency of vibration of the water molecules matches with the microwave frequency. So when the microwaves hit the water molecules, they also vibrate with very nice amplitude. And when they vibrate with very nice amplitude, there will be thermal energy, kinetic energy, which is created, and hence the food indirectly gets heated up. Yes, understood my warriors? How the food gets heated up? So that's the application of your microwaves. Then obviously infrared waves are slightly above the red wavelength, slightly longer than the red wavelength. So if you see the spectrum, it's slightly above or to the side of red color. They are slightly longer in wavelength, and infrared is emitted by your human body. Yeah, so we all know radiation. You would have studied this in 11th. Modes of heat transfer, conduction, convection, radiation. So any body which is hot radiates heat, and the wavelength in which you emit heat depends on your temperature. At your current body temperature, you radiate heat in the range of infrared. Have you seen, obviously during corona times, somebody stands with a scanner and places it on your head and they see the temperature. How many of you have seen that? How many of you have seen that? Why don't they use a thermometer, put it under your arm and then wait for 5 minutes, and then they see your temperature and then they see, okay, you are fine, okay, you can go. Next, okay, raise your arm, put the thermometer, and then they do this. Nobody does that. Why? Because obviously it's time consuming. But how does this wireless sensor work? Mansa remembers, Gokul remembers. This wireless sensor is based on your infrared heat. So basically it detects the wavelength and then it corresponds and correlates it to the temperature. Yeah, it correlates it to the temperature, back calculation using Wien's displacement law. I hope you remember Wien's displacement law. Wavelength and temperature are inversely related to each other. So, our body temperature, as it changes, the spectrum, in the infrared also, you will change from this point to this point or this point to this point. Detecting that, you can figure out whether you're hot, you have fever, or you don't have. All right. Now, visible range, everybody knows. We start with VIBGYOR, violet, indigo, blue, green, yellow, orange, red. So these are the colors. Violet obviously is the strongest in frequency, very short wavelength, very high frequency. Wavelength is 400 nanometer, you should know that. And red corresponds to close to 700 nanometer. Yellow comes somewhere close to 550 and 600 nanometer. Okay, so I hope now it has been answered how your wireless thermometer works. So this range you should know. I don't want you to remember individual wavelengths. No, only remember the extremes. 400, 700. What is the average of 400 and 700? It will come somewhere here only. That is your yellow color. Okay. Then you have your ultraviolet. Ultraviolet rays usually come from the sun. like I'm wearing these spectacles exactly to block the UV rays. There are harmful rays which can come out from all these lights, which can be damaging to your skin and your eyes as well. So I'm protecting myself from all of that. And ultraviolet rays can obviously cause skin cancer, and they obviously affect your skin. Okay, so you should definitely protect yourself from UV rays. They are of high frequency. You can see it comes slightly after the violet color of higher frequency, short wavelength. Then you have X-rays. X-rays are even high frequency, even small wavelength. In fact, the wavelength of X-rays is very close to the atomic dimensions, meaning the wavelength is in angstroms. So that's the reason why when X-rays passes through crystals, they see these crystals like small openings and they get diffracted. And that's why you use X-rays for studying the structure of the crystals as they pass through all these solids. Other sources of light or other waves, their wavelength is not similar to the gaps which are found in atomic crystals. So that's why you cannot observe diffraction using visible light or even gamma rays. But X-rays, the wavelength is similar. And there is one essential characteristic of diffraction. If you remember, diffraction occurs very nicely, it's very vivid and clear when the wavelength is close to the aperture size, when the opening and the slit widths are close to the wavelength. So it happens so with the X-rays. That's why it is used for that. Not just that, it is also used to detect fractures, because bones stop the X-rays, whereas muscles and flesh allow the passage of X-rays. So you can see where the fracture is, depending on if there is a crack in your bone, the X-rays will pass through and you will see the photographic plate will get exposed. I hope this is clear. All right. Definitely Abhijit, but probably this is in the term 2. Maybe you might face a little bit of difficulty, but it's fine. Hi Rose, no problem. AR Pavitra, glad you are here. Watch the replay later on. Okay. Yes. So next thing is gamma rays. Gamma rays are very harmful. They come from nuclear explosions, nuclear reactions which occur. So they are very high energy, very short wavelength, and they are very highly penetratable. That means they can penetrate through many things because of their high energy, and they can also ionize the gas through which they pass. Okay, so usually they are produced in nuclear reactions. That's something which you should know. Let's start with some questions coming up on your screen. Okay, so the speed of electromagnetic waves in vacuum depends on the source of radiation. So it increases as we move from gamma to radio, decreases, or is it same, or is it none of the above? Okay, come on my warriors, figure this out. What happens to the speed of the wave in vacuum as you go from gamma to radio? Does it increase? Does it decrease? Does it remain same, or none of the above? Yep, obviously a lot of people will think, sir, C is nothing but F lambda, because you are going from gamma to radio, so your frequency is reducing, so C should reduce. No. C depends only on the medium, so it's vacuum, so C should definitely remain same. As frequency goes down, wavelength goes up. That's it. Yep, so hence none of the above. Next, yeah, so not none of the above, it's same for all of them. Yeah. Okay, so which of the following electromagnetic waves has the longest wavelength? Come on, let's see how many of you recollect. Do not go back, do not go, cheat. Let's see how many of you can get this. Ultraviolet, infrared, X-rays, visible rays. How many of you remember the electromagnetic spectrum? Let's see. Probability is very less. There have been 2-3 instances, at least in the past few years, where they have directly asked questions based on the electromagnetic spectrum. Just in the last 2-3 years. In so many shifts, yeah. Okay, perfecto. Some of you got it. The answer is infrared. The question is, which of them is longest? Look at the spectrum. Where is that spectrum gone? Here. Yeah, infrared. Options did not have radio and micro. If that was there, then that would be the answer. Infrared, visible, UV, X-rays and gamma. Infrared has long wavelength. Here the wavelength becomes shorter and shorter. Yep, so hence the answer for this question is infrared. Out of this, which has the shortest wavelength? Come on, let me see who can answer that. Come on, quickly. Which has the shortest wavelength out of these 4? Is it ultra, is it X, or is it visible? Which one it is? Come on. Obviously, now you know this. Yeah, is it visible? No, it is X-rays. X-rays have very short wavelength as compared to all of the other one. Very good. Moving on to the next question. Which of the following electromagnetic waves is used in medicine to destroy cancer cells? It's called as radiotherapy. So how many of you know this answer? Let's see. So very interesting application of electromagnetic waves. Which of the following electromagnetic waves is used to destroy the cancer cells? Is it infrared? Is it visible? Is it gamma? Or is it ultraviolet? Okay, it's going to be an interesting answer. Looks like some of you know it. Okay, yes, the correct answer is gamma rays. They are very harmful. So actually speaking, you should never stay in front of gamma rays. They have very bad side effects. If they can destroy cancer cells, they also destroy your normal cells. So it has to be done under a lot of care and precaution. X-rays themselves are destructive. Gamma rays are even more destructive. So they are used to treat in medicine. Okay, it's not UV. UV will cause more problems to your skin. It will cause skin cancer. So you don't use UV bacha to treat it. UV will cause skin cancer. So you want to treat cancer. So you're not going to sit under UV. Please don't do that. Okay. So I'm pretty sure many of you are going to become doctors. How many of you are going to become doctors out here? I want to know. Hulk is a result of gamma rays. Maybe. I don't know. Okay. So Sri Krishna sir is doing a dual degree of BSc in MS or doing 4 years BSc in Kanpur. Oh no, none of them. I'm done studying. Oh, Naveen is going to be a doctor. How important is nuclear for JEE? One question you can expect. Yeah. Okay, Maxwell, we have, sir, when will I take semiconductor? Simply Wolf, can you check my upcoming sessions? I'll just show it to you right now. Okay, I think we're done over here. So guys, right now while you're watching the video, okay, you can see upcoming playlist. Oh, do you see this? Semiconductor. You see semiconductor electronics, upcoming live streams. Right, tomorrow 7 o'clock I'm going to take semiconductors, and in the past videos you will be able to find my nucleus, atomic structure, waves, all of that I have covered, guys. Okay, so you can watch it. Okay, I can see many of you are going to be doctors. Interesting. All right, so guys, while you are watching this video, there is also a very important thing that you need to do. So just go down, and when you see over here there are multiple links for JEE and NEET students. Now this is basically the crash course links. So many of you probably are already in some batch or maybe in some coaching. If you are in Vedantu, then this is a part of Vedantu. You already get revision and test series. But maybe if you are not a part of Vedantu, or not a part of All India ranked test series, maybe you want to see and face the real competition. Let me tell you, a lot of students are there in Vedantu. It's not like 100, 200. So you get to know where you stand at the national level. So, you know, there were thousands of students last year alone who cracked JEE Advanced, 1,500, okay, to be precise. Okay, 1,500 plus students who cracked JEE Advanced. More students who cracked NEET, more students who cracked, you know, your JEE Mains exam. So you get the real picture because you are, you know, participating in the real competition. Not just that you get assignments, you get tests, and you also get your lectures. So let's say, for example, the JEE crash course right over here, physics, chemistry, maths. I am teaching in the crash course, so you get me as well, and that too, it's available in English, also in Hindi plus English, whichever mode you prefer. Clear your doubts instantly because you get 2 teachers in the class, all India mock tests, live classes, live interactive classes, also, you know, tips and tricks, strategy sessions, everything. And this is all for just 1,800, 5 weeks duration. You might be wondering, sir, board exam clashing. Don't worry, you can watch it later on. This validity is there till the last day of the exam. So don't worry, even if it gets postponed, it will be still valid. It's just 1,800, click buy course, it's done. 200 rupees you saved. Same thing for the NEET crash course as well. So the NEET crash course, again, 20 tests, you have 120 sessions, crazy, 500 quizzes, live doubt solving during the class. Again, for 1,800, 5-week duration. Don't worry about board exams. The validity is still there. Recordings are available, so you don't really have to worry about it. Multiple payment options again available. So I'll be waiting for all of you in the crash course. Like many of you know, I'm teaching physics in the JEE crash course as well. So make the best use of the crash course because it's at the most affordable rate, and I'm pretty sure many of your friends and relatives will be interested. Today's session is going to be available as a PDF with my handwritten notes, everything in the Telegram channel. If you have not joined, make sure you join it. And thank you for making this family grow. We are now 1 lakh subscribers or 100K, and thanks a lot to all of you. And I'm so glad, Paray, keep this juice high. Thank you, Naveen, so much. It means a lot when you write all these nice comments. And please put up all your lovely feedback and comments in the comment section below, because I do read them. Okay. Will you make short shots? Yeah, not JEE this week, but I'll be doing board sessions next week. This week, I intend to complete your term 2 syllabus, all right? Term 2 from JEE and NEET perspective. All right. Thank you so much, guys. And yeah, it's some big milestone. And without you guys, it would never be possible. So stay tuned for more. Tomorrow, 7 o'clock, semiconductors, of course, on this channel of yours for both JEE NEET aspirants. Till then, take care. This was Captain Shreyas signing off. Hasta la vista.